All right, hi guys. So today what we're going to do, we're going to continue our study about limits. In the last couple of lectures, we were working on specifically looking at limits on a graph. Great. Hey, if I have the graph, it's super easy. Just look at which way it's going. Then we went to in our last lesson. What if I don't give you a graph? What if I just give you the equation? Can you figure out what that would look like? Okay, what that would look like. Now today, we're going to continue that trend. We're going to look at it in two different ways. We're going to not look at easy equations. These equations are going to be a little hard. If you guys want, you guys can go ahead and go to the homework number 27, the PDF, pull that up, and you'll see pictures being drawn already. So here's a couple examples of, we're looking at what we call piecewise functions. Piecewise functions. And the reason why they call them piecewise functions because they're made up of pieces, okay? It's not just one equation. It could be many different types of equations, many parts. So let me give you an easy one. What if I write y is equal to not just one equation, but y is a set of equations where it will be a parabola on one side, x squared, when x is greater than 0. Can say greater than or equal to 0. And x is, let's do x plus 1 when x is less than 0. Now, why do we have these crazy, weird ways of writing things? Because not everything can be shaped with just one equation. Like, let's say your personality. When you guys wake up in the morning, you have one personality. At the end of the school, you have another personality. When you see your parents, you have another personality. You change forms. And it's not always predictable, especially high schoolers. So let's look at this graph here. I'm saying, so I'm going to draw this real quick. Hopefully you guys can notice a color change. I'm going to use blue here, and I'm going to use red here. So when x is greater than 0, hopefully you notice that x is greater than 0 on this side of the graph. And x is less than 0 on this side of the graph. So we actually have different graphs we're going to need to draw. You act differently in different situations, different times of days. So is this graph. When x is bigger than 0, that's on the right here. The graph looks like a parabola. I'm going to put a dot here and just draw a simple parabola. But on the left side, when x is negative, that's plug in. What does the graph look like? And the graph actually looks like this. Okay, and I'm going to put a hollow point. Everyone please notice this is hollow. And the reason why is I am not equal here. I am not equal to 0, so I'm not allowed to be there. Okay, so how do I know that line is looks like that? Well, this line is actually this line here, with the y-intercept at 1 and the slope of 1 over 1, 1 over 1, 1 over 1, 1 over 1. That's the graph that we were supposed to draw. But are we allowed to continue the graph after 0? Remember, this graph only exists before 0. So at 0, it stops. It's almost like there's a wall there, and it can't get past it. Once we were past 0, or at 0, we switch equations. You guys ever hop on different, you guys have been on the train and you guys have been on the bus, right? After the bus stops, you get off and you hop on another mode of transportation. Because maybe that one bus doesn't take you all the way home. Maybe you have to hop on a couple of buses. And this is the idea of this piecewise function. We are riding, let's say the train to 0, get off and hop back on our bus to take us home. Now, it's kind of cool once you understand piecewise functions aren't as difficult as they may appear to be. They appear to be difficult oftentimes because there's so much stuff going on. There's more than one equation. It was already hard before, and then it seems like I made it harder. But really, you can just cover it up. Another way of looking at it real quick, take a look at this ruler. For anything less than 0, we have a line equation. Anything after 0, we have a parabola. Okay, how do you know when to graph it? Here is one trick that I find that's pretty easy. Just plug in this number. Just plug in this number. If x is 0, what's 0 squared? 0. So right here, we're going to start 0, and we're going to become a parabola on the right side. But on the left side, if I plug in 0, what's 0 plus 1? 0 plus 1 is 1. Hey, I'm going to put a hollow because you're not allowed to be here, not allowed to be on it. And the slope is 1 over 1. So I'm going to go backwards, 1 over 1, 1 over 1, 1 over 1, 1 over 1. Okay. Now we're going to use this and we're going to talk about some questions I'm going to ask you guys based on limits. So here's the first question. What is the limit as x approaches 0 from the right side of f of, or we can call it y? Okay. What is the limit as x approaches 0 from the left side of y? What is the limit as x approaches infinity of y? And what is the limit as x approaches negative infinity of y? So we have 4 questions here to talk about in which directions, what does the graph look like? The limit says, remember, what does it look like? So I'm going to have you guys type in the chat as fast as you can. When I ask a question, you're going to type in the chat, and we're going to see if you guys get it right. If you're scared about other people reading your work, just put it on private, okay? You can private it to me. So the first question, number 1, what is the y value as we approach, as x approaches 0 from the plus side, from the right side? So let's see if you guys can guess it. I'll give you guys 3 seconds to see if you guys can figure out what that answer is. What is the graph look like as x approaches 0 from the right side? If you could type in the chat in 3, 2, 1. I got a couple answers, and those answers are both 100% correct. If I'm approaching from the right side, you can see the graph gets closer to 0, not the left side. This little plus sign refers to right. So we're getting to 0. See, this is 0, right? But we want to hit it from the right side. Give it a right punch. Okay, let's go ahead and look at the next question. Let's see if you guys can figure this one out pretty quickly. What is the limit as we approach 0 from the negative left side? In the chat, in 3, 2, 1. Go ahead. I'm here seeing 1. I'm seeing negative 1. Let's see, from the left side, if I'm walking up to 0, you can see hopefully I'm actually hitting positive 1 here. Because I'm looking not on the left, not on the right side. See, this little negative sign means left. That's a big word for left. So I don't have to write it. So I'm still getting closer to 0, but this time approaching from the left side. Sometimes you guys have went to your friend's house and you approach from the wrong direction and you're like, I don't see your house. And you're a little spun around, you're a little confused. Things look differently from left side and right sides, right? My face on my left side looks different from the right side on my right. You guys all, if you guys take a lot of pictures, you guys have like a preferred side, right? And that's the same thing here. Not everything is always the same from both sides. And that's what limit allows me to say. Look at it from the left or look at it from the right. What is it going to be? Okay, so let's continue with this conversation. What does the graph look like if I could go to infinity? As x goes to infinity, what do you think the y value? What happens to the y? Do you think it's ever going to stop? I would say it looks like it's going to be taking off to infinity. So this idea of saying, what does the y look like? There is no answer. It's not like it's going to look like 6. No, it's going to keep on going forever. And that's okay for us to write infinity. So let's refill this in. I'm sorry, this was 0, this was 1, and the next one is infinity. Let's look at the left side. What if we go to negative infinity? As I go toward negative infinity this way, what's your y value? Your y value dips down to become negative infinity also. Okay, thank you, good job. So this is us describing what does it look like. Do we really, for infinities, we don't need to know, oh, the answer's 5. I don't know, it's 5. This goes on forever and ever and ever and ever. And x squared, as I keep plugging in bigger x's, it's going to keep on going. Okay. So let's do another problem here. I'm going to give you guys some more values. This is going to be negative 1, 2, 3, and negative 3. Okay. So I have a couple questions for you guys, and you guys are going to tell me what this piecewise function is going to look like. What's the limit as x approaches negative 1 from the left of f of x? Call this f of x. What's the limit as x approaches negative 1 from the right side of f of x? And then what is the limit as x approaches negative 1 of f of x? That's our first question, and then we're going to come up with some other ones. So for these three answers, let's see if you guys can fill these three answers out yourself. I'll give you guys just a couple of seconds after you guys copy it. Okay, so from the right side and left side, let's take a look here. So as we approach from the left side, what's my answer? You guys can type in the chat. What does it look like? It's going to be 3 or 0. You guys answer in 3, 2, 1. I'm hearing 3. That is correct. Because if I'm approaching from the left side, the y value at -1 is 3. But the question is it really 3? The point of a limit is not to tell you what it is what should it look like. And it looks like it should have been, last time I checked, it looks like it should have been 3. If I approach 1 from the right side, that is going to be 0, right? The y value is 0 there. But my final question here is, does the limit actually exist? If I call in and the left side says 3, and I call in on the right side and the right side says 0, do they agree? And if they don't agree, we say something. We say this is a limit or no limit. We say there is no limit. And that's something we want to go back to remember, that not everything has to look like something. Because sometimes you have no clue, because none of the evidence leads you to a conclusion. And we don't want to say it looks like something when it doesn't. And that's okay. It does not exist. There's no limit. Now, let's go ahead and look at going back to the piecewise function. If I give you this function, what does y is equal to a set of 3x and when x is greater than 4, and negative x plus 1 when x is less than or equal to 4. So I'm going to ask you a couple questions here. Got it. What is the limit as x approaches 4 from the right side of y? And what's the limit as x approaches 4 from the left side of y? Okay, we can call it f of x and call it y, we can call it whatever we want here. Let's see if you guys can figure out what this answer here is without me even drawing the graph. So we did it with a graph, now we're going to do it without the graph. Now, to help you support you here, I'm going to draw a number line, and I want you guys to see this real quick. This is an easy way for you guys to clear things up in your brain. When x is greater than 4, we are on the right, right? When x is less than 4, we're on the left. So this is my left equation, and this is my right equation. Okay, just for a way for us to make sure we understand that in our brain. I don't have to draw the graph, but it is helpful sometimes. And in this case, I'm just helping you at 4, which one is the right and which one is the left. Well, looking at our first problem now, what is the right side look like? Well, which one is the right? Is that the red or the blue? Are numbers on the right bigger than 4 or less than 4? Numbers on the right are bigger than 4. See, I'm bigger than 4. So how do I figure out what the answer is? Well, if we're saying 4, can we just plug it in? It looks like 3 times 4 is 12. I don't really know if it's there. In this case, it actually isn't there. Because am I including 4? I am not including 4. So that's why we can say it looks like it should have been 12. I get it. It's probably like 3.99, no, you say 11.9999999999999999999. That's what it kind of looks like. But we can say it looks like it should have been 12. What does it look like on the left side? See, I'm not saying -4. I'm saying on the left side here. So here's my left side equation. That looks like, let's plug it in, -4 plus 1 is -3. So the way we find left side and right side when it comes to an equation is just literally plug it in, plug that number in, and tell me which side am I asking for, the left or the right. And really, that's how we do piecewise functions. Now, sometimes you end up with a problem that looks like this. Y is equal to the absolute value of x plus 2 over, let's say, x plus 2, okay? Now, you could divide this out and it would have been great. But what is the limit as x approaches 2 from the left side? And, sorry, a y, that's right, y there. I wrote y. And what's the limit as x approaches 2 from the right side? Now, here's a part that's a little tricky. Because we can't use certain algebra tricks on the problem because of the absolute value. So this is what we're going to do. We're going to split it. Absolute values always have an issue. Everything's positive. But I'm going to split it, and I'm going to show you guys whenever you have absolute value, you can always split it, and we can trade it for a positive and negative version. A positive x plus 2 and a negative x plus 2. Now, when do we use each of these? Well, let me ask you this question here. If x was 0, 1, 2, or 3, do we really need an absolute value sign? What is 0 plus 2? That's positive 2. We're good. What about 1? If I plug in 1, 1 plus 2 is 3. We're good. 2 plus 2 is 4. We're good. 3 plus 2 or 4, we're 5. We're still good. They're all positive. But is that true? If I keep going down the number line and I plug in negative 1, negative 1 plus 2 is still positive 1. What if I put negative 2? Is negative 2 plus 2 positive? It's 0. So we have a problem here. Right at negative 2, we have a problem. What about if I kept going and put negative 3? Is it negative 3 plus 2 negative 1? Now we need the absolute value sign. It's kind of our backup. So we hit a problem. At negative 2, here at negative 2, we end up having to use our absolute value sign. So how can I make that negative back into a positive? We give it an extra negative sign. So this is how this piecewise function is created. We have x plus 2, y is, okay? But when x is greater than negative 2, when x is less than negative 2, and that's our little dilemma here. What happens when I'm at negative 2? It's actually going to be 0 over 0, and that doesn't exist. But if I was a little bit to the right of it, we would be positive. We would use this positive version here, as if no absolute value existed. But if it was more negative than we wanted, we need our backup plan. We got to go call in that negative sign. Okay, so here is our dilemma. What does the graph look like on both sides? Well, if you plug in negative 2 here, let's do it. If I plug in negative 2 to the problem, negative 2 plus 2 is 0. And then negative 2 plus 2 is still 0. Aren't we still 0 over 0? I want you guys to notice something. Doesn't x plus 2 and x plus 2, don't they divide out? And that actually becomes positive 1. Doesn't x plus 2 and x plus 2 divide out? That equals to negative 1. It turns out this is actually a special case graph. And the graph here looks like this. When x is negative 2, we are positive 1 on the right, and we are negative 1 on the left. This graph looks super confusing, but let me go ahead and plug in numbers for you. If I plugged in 1, what's 1 plus 2? 3. And 3 divided by 3, that's back to 1. If this was 2, 2 plus 2 is 4. 4 divided by 4 is still 1. 3 plus 2 is 5. 5 plus 5 is still 1. It's always 1. It just wasn't obvious for us. But when I was able to separate it, here, we realized that we could divide it. We have a left side and a right side. Oh, sorry, right side and left side. And these type of graphs can be tricky. It's just playing with the equations and seeing where does the absolute value lead you. Now, what are the limits? Well, the limit on the left side, let's take a look at this again. What is the limit on the left side? The left side is this guy here. The left side is going to be negative 1. And the right side is going to be positive 1. Okay. All right, that's it.